Hi friends, welcome to this class. So we shall see few more examples of this same reaction, right? So see here. Here I have taken one example. Here nitrogen, I have told nitrogen heteroatom should get one position 1, 2, 3, 4 and 5. Fifth carbon having hydrogen. It should have hydrogen. So we can mention it as 6. So it will form 6-membered ring. Initially I have told, like radical mechanism it will go through, right? So it will form 5-membered ring, but the final product will be 5-membered ring. 6-membered ring will be like a transition state, but not the product. Product will be, major will be 5-membered ring. The exception I have told you that, right? So what happens? First radical H plus will attack. It gets positive charge at photochemical or thermal condition. It will cleave homolytically, and here also homolytically, and bromine will attack here. Right, here the bromine will attack, and here the proton will attack, and nitrogen will be having positive charge. But in presence of base, what happens? The base takes this proton and nitrogen gets its lone pair of electron. Here two hydrogen will be there. Okay, one hydrogen will be left and lone pair of electron it will get. Right. So then what happens? It will undergo SN2 reaction, and nitrogen, as it gets positive, it takes the electron density to form hydrogen, so H plus, and here Br minus, HBr is formed. The byproduct will be HBr here. Till now I haven't told, but these things you know, so not necessary to tell, right? So again we will get the product will be like this. It is a 5-membered ring. I can show like this also. Here methyl and here nitrogen. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. This is the 5-membered ring, and here ketone group as usual, and nitrogen is having R group, right? So this is the 5-membered ring, we will get it. So this is tertiary butyl group. So here also if we do the reaction, see here nitrogen 1, 2, 3, 4, 5th carbon having hydrogen. So here ring formation occurs like this. So the final product mechanism you know. So no need to tell me again and again, right? This is linkage, oxygen linkage, and here nitrogen. AC group you should know. AC means acetyl group. AC means acetyl, like CH3CO, and here linkage will be there with here CH3 group, CH3CO and some linkage. Here N linkage is there, CH3CO. N acetylation we call it reaction somewhere, N acetylation reaction. So this is N acetyl group, right? And here chlorine will come, and here it will form bond. So it is 1, 2, 3, 4, 5. It will form 5-membered ring. Here also 1, 2, 3, 4, 5. 5-membered ring. Those will form, right? So the first application we have studied. This helps in natural product synthesis, right? So natural product synthesis containing ring, there also it will have. See here, if I do same 3 conditions. First one is acid condition, H2SO4, and second one what we had? Second one we had photochemical thermal condition, and third one will be the base, right? So if I do the reaction, see here 1, 2, 3, 4, 5. 5th carbon containing hydrogen, right? Then it will chlorine will come here, SN2 reaction. So I will get this structure, 5-membered ring, and here COH is above the plane and hydrogen is below the plane. These structures you should know. Like a dark mark if you show, it is above the plane, right? Above the plane, and this is below the plane, and these are in single plane, and here it will get hydrogen, right? Nothing else is there, and lone pair of electron. If you see it, it is nothing but L or S proline we call it as. L or S proline. So using this reaction we can synthesize S or L proline using this substrate, right? And the conditions are same as it is. So these are the application part. You can note it down along with me, right? So let us see what happens in this condition. Here also same 3 conditions. Here nitrogen 1, 2, 3, 4, 5. 5th carbon having 6th hydrogen, right? Here it can form 5-membered ring again. So the product will be, I am going to write the product directly. Yes. Here it has oxygen, here also oxygen, and here see here, this is the thing, CH3 group and nitrogen. So 5-membered ring. 1, 2, 3, 4. This is 5th carbon. Sorry, okay, it is nitrogen, right? It is not carbon. 5. This is the structure. 5-membered ring. It has formed. See here. 1, 2, 3, 4, 5. 5-membered ring. I thought it is carbon here. No, it is just hydrogen here. So this is the 5-membered ring. And same way here, if I do, see here, this is very interesting. You should remember it, right? So this is very interesting. See here, what happens? This nitrogen is a ring nitrogen which is above the plane. See here, they have shown them above the plane, right? If I number, see here, 1, 2, 3, 4. Here also methyl group, here also methyl. This is also 5 and this is also 5. 4, 5 or 5. But as this nitrogen is above the plane, I told it will form during reaction, it will form like 6-member transition state, I told. But it is not the transition state, but to understand purpose I have told, right? To form that 6-member transition state with this hydrogen. See, here also hydrogens are there, here also hydrogens are there. 6th hydrogen and this is also 6th hydrogen, right? It will form only with that hydrogen which is above the plane. See, as this carbon is above, it will form the 6-member transition state with above hydrogen. Then it will form 5-membered ring with above only. It can't form from below because it is above. It is below. The distance will be very long for this carbon, right? Carbon and hydrogen. But here it can easily form. So if it is nitrogen is above the plane, here this carbon should also be above the plane. So it will form a ring like structure here. Like this also I can show it. 5-membered ring it will form here also. And this, see here, this nitrogen is above, right? So it can form only bond between one which is above. I can show here. This is methyl and this bond. See here, 1, 2, 3, 4, 5. And this methyl will be below the plane, so it won't form with that, right? And other thing as it is here, benzene ring as it is, right? So like this they will form 5-membered ring, but some cases 6-membered ring when at 5th position carbon is absent. If any other heteroatom is there, then only they form like that, right? So let me take this more example. So what is this? This is nothing but steroids. Steroids we have studied, right? The same steroid. Here angular methyl groups are above the plane in steroids. Those things you need to remember. So this is OH, right? See here. This nitrogen is attached to that carbon which is above the plane. So it will take the proton from that carbon which is above the plane. That thing you remember. 1, 2, 3 and 4th carbon, 5th carbon. Why only this carbon? Because it is above the plane. And here 6th hydrogen is there. So it will form a ring. So my final product will be like this. So 5-membered ring it will form. And here it has got methyl, so this is the methyl. And other position as usual methyl OH, right? So as usual, so it has formed 5-membered ring. Let us see few more examples and then we will conclude this named reaction, right? So one more example. Yeah. Okay then, see here, this is also very interesting. This is also a colonic ester, like that one was steroid, right? Colonic acid derivative it was. And now let us see one more example. Benzene ring it is, and here sulfur containing S double bond O. This compound is there, and here methyl and here hydrogen. Here no heteroatom they have mentioned. But in reagent part they have given some reaction like PHI OAC twice iodine. They have mentioned second condition in light condition they have mentioned, and third condition hydrolysis they have mentioned. So the mechanism how it will happen. See, this reagent is there, right? So this reagent will do methylation, right? So it will do methylation, like see here. So what happens here? It will do the reaction like this. see here, if I mentioned here methyl, let me write here hydrogen, it has got lone pair, let me show here. Because of this reagent here CH3 group is there, it will be replaced by Ci3. If I now see here 1 2 3 4 5, it can easily form 5-membered ring. So SN2 reaction, one iodine will leave, so we will get the product to be like this, 5-membered ring, right? So here yes, double bond O, and this is 5-membered ring containing nitrogen atom here, and it is attached to methyl group, right? And here 2 iodine is there. This happens in presence of this catalyst and H nu condition, right? This is homolytical cleavage happens and the reaction will occur, right? And this is the product we will get. And the third condition is hydrolysis. If I do hydrolysis, iodine will be replaced by OH and OH. And we know that 2 OH group can't be present on one carbon. Those will be highly unstable. So what happens? OH and H will leave to form ketone structure, right? This thing you know, right? Here what happens? H will be there, right? This lone pair takes this proton and this electron density moves here and it will take the electron density. So there will be water elimination and we will get a ketone group like this. This mechanism you know. Here what happens? I'll get a ketone like structure, and here methyl is there. So this is nothing but amide bond will be called RCONH, CON amide like structure, right? So this is the thing. So this mechanism you know, I hope. What happens? It will take this proton, so it becomes OH2 plus. To neutralize plus, it will take the electron density here. But what it will do, from this electron density it has taken, it will give here. So we will get double bond O, and other things as usual, same, right? Similarly, last one more reaction, let us see that reaction and we shall stop it. So the reaction is, see here, OCH3, N, sorry, it is not C. Here C is there, here N is there, and it is protected, Bock protection, you know that, right? N can be protected by Bock. H, and here methyl group, and here above the plane oxygen like this, right? So see here 1 2 3, right? Let us see 4 5 and those things, let us see, right? So reagent, let us check. First one is PHI OAC twice in iodine medium and photochemical condition, same as it is. See here 1 2 3 4 5, and this is 6th hydrogen, 5th carbon containing 6th hydrogen, right? So cyclization occurs like this. So what we will get? We will get the structure to be like this: below the plane OMe, below the plane OMe, above the plane OMe, and here methyl group which is below it won't take any form here. Since it is above, it will take from this proton only. So what happens here? Ring formation occurs. Nitrogen which is protected by Bock, and here which is above the plane, this carbon is above the plane. So here 5-membered ring, 1 2 3 4 5, 5-membered ring, and this is methyl group, right? So this is the product we will get. So in next class let us see with few more named reactions.